Hi, welcome everyone in analog layout video series. In my previous video, I demonstrated that how should match the differential pair, as well as I also explained the importance of matching for the differential pairs especially, as well as in analog circuitry there are various things that you should match, such as if there is any current mirror as well as any current reference circuit and so on. But however, in today's video, I will show you that why we need Dummy transistor, and secondly, I will demonstrate that how to use this Dummy transistor. And in practically, I will also demonstrate you to that how I used Dummy transistor for my demo videos, which basically I am preparing for the YouTube purpose. As well as in this video, you may not expect that you will learn the similar thing whatever we are practicing in the industry basically, but I will want to give you some idea, especially the students who basically are really enthusiastic about analog circuitry as well as analog layout. So I think that this video will be helpful for them. And during my video tutorial, one thing you definitely learn that how basically engineers use dummy transistor professionally. But however, as my tools which I am using to prepare my videos, it is not in standard in industry. Industry standard meaning there are not all features are available. So I cannot show you everything, but definitely I am give you some idea that which will help you to get you job, as well as in these basic ideas also help you to learn how you can do analog layout matching especially perfectly. So let's begin the video. So I would like to share you some uh, documents basically from my screen, and after that I will go to in my Cadence window and I will show you that how I use dummy transistor for my differential pair. However, in my next video I will also show you that how should route the differential pair or anything in uh, any circuitry in Cadence or Synopsys in any compiler. Basically these are the different thing that I will share step by step process. If I will share everything in one single video, it not be a wise decision. So let's uh, focus now why and how to use dummy transistor. Then in my next video I will definitely share some more knowledge with you, and I hope that you like my video as well as share with your friends. Basically I will also feel some motivation if we do that. So first of all, let's study why you need dummy transistor for analog layout. There might be various reasons for using dummy transistor, but uh, I am sharing with you one most striking feature that you should keep in mind whenever you are a layout engineer, especially working in analog portion. There is a phenomenon which is known as well proximity effect, or in short WPE. And if you study about the CMOS or MOSFET fabrication process especially, then you can learn that there are several step-by-step process. And among these, one of the most crucial step is ion implantation. And this ion implantation process, which is a non-uniform process basically, and due to this process basically there's something occur, and this phenomenon is known as well proximity effect. I mean, what occur basically here actually? So without any complex definition, I would like to say that WPE is due to your device near well edge. Let's say you have some devices here. How can I say? Okay, mm, just a moment. Share. If I share with you the whiteboard, then it will be easy. Let's say you have here 4 devices here. Right now, forget about the connection and everything. I just want to say one simple thing. And this is the basically the poly layer I draw here. This is the vertical layers are poly, and let's say every layers here, every 4 transistor, these are my active transistor. Okay, and in the ion-implantation process, basically, let's say it is my drain terminal. Let's say it is also my drain terminal, and due to the ion-implantation process, this active transistor basically have some impact there. Mean, yeah, okay, what impact I will explain you later. But let's say if it is your uh, active transistor here, then the H transistor mean, let's say this is the right edge transistor and this is the left edge transistor. These 2 transistors are affected by WPE. And what will happen here, I will show you with some image that you can understand it easily. But let's go to my documentary first. Here uh, basically the atoms are can scatter literally from the edge of the photoresist mask. If this types of definition is very hard for you, you can just imagine, let's say it is the transistor of the 2 corner. I show you 2 corner transistor, right? And you can assume this is one of the corner transistor, and due to the WPE or well proximity effect, which will occur during the ion implantation process, the H terminal, sorry, the H MOSFET, would be look like this. Let's say this is the your most outer terminal of your MOSFET, and due to non-uniform ionization, it looks like not ideal. Mean, you drain terminal, you can see it is safe, it is a straight line or a plane, but this source terminal may affected due to the WPE. So we should protect this transistor, because if it will occur with this transistor, then there might be or there should be my threshold voltage mismatch. And for crucial analog circuitry, such as I'm giving here some example, let's say differential pair, which I'm making video right now on this topic, and I also show how to match this differential pair. And for this differential pair, let's say there are 2 transistors, and if there is any threshold voltage mismatch, then the designer, which they expected in their pre-layout simulation, they definitely will get similar response after post layout. Mean, after doing the layout, they surely not get the effective gain and the phase margin, the current limit, everything whatever they calculate. For example, the corner process, so they will lose their performance. Basically, they lose their circuit performance. The crucial circuitry, there are other some, let's say for cascade current mirror, where current is copying, or for example, there may be the OPAMp. This differential pair is maybe a part of OPAMp. There might be various type of OPAMp in industry are using. For example, folded cascade is very popular there, as well as telescopic OPAM, two-stage OPAM, and so on. And There might be some current reference circuit look like this, where current is copying one branch to another branch. So these types of circuit, actually the matching is very, very crucial. Is very vital and very indispensable basically. So you should be careful about with WPE. For digital circuitry, where basically the voltage is shifting from one level to another level, where VGS matching, the VDS matching, threshold voltage matching is not too much important as like analog circuitry, because analog circuitry may easily affected by the temperature noise, or it can, if there is any supply voltage mismatch, threshold voltage mismatch, any kind of mismatch, analog circuit surely loses desired performance, whatever the designer expected from this circuit. They surely not get these types of response after the layout as well as after fabrication also. So we should careful about this. And any interview, they surely ask you that why we are using dummy transistor for analog layout. Then you should say well proximity effect. To resist this well proximity effect and to save our the corner transistor, we are using the dummy transistor. Okay, I hope this point is very crystal clear. Then now let's talk about how to use this dummy transistor professionally. I would like to make this video very small, otherwise it would be large. So very quickly, I'm telling you that how to do that. Let's say I have four active transistors, two A and B. Let's say you have two devices, A and B, and each one has two individual devices. So let's say it may be a current meter, and okay, I will make a separate video, but for I'm telling you with responsibility for current mirror, you must do some interdigitized type matching, and for differential pair you must follow the common centroid matching. And I surely make a separate video, especially for the current meter, why we need the interdigitized matching for that. And whenever I will make video on current meter, I surely follow this circuit. Then you can understand it's very well. But right now, let's focus that A, B, B, A. It is an interdigitized type matching. And let's say this is my active transistor. Now I use, this is my corner transistor, right? So I use dummy here, as well as I also need dummy here. In addition, I also need dummy top of this transistor as well as the bottom of the active my transistor, because to protect A, B, B, A, this active transistor from WPE impact. However, I would like to show you one image also, that what you can understand easily. Yeah, if I zoom this image, let's say this is my active transistor. Okay, 1 2 3 4 5. Let's say there are 5 transistors. Okay, and this is the photoresist. You can see in the bottom right and left corner, as well as in here you can see that ion-implantation process has been doing here. So due to this ion-implantation process, as I told you, the the left and right corner transistor may be affected. Okay, and you are showing that this drain as well as this source node is if affected by WPE, then it surely loses its performance. Furthermore, this effect can be happen in my drain node also, in the drain terminal of the transistor, because ion are putting from top of this. So you can imagine this, or if you will enjoy any video on YouTube how this fabrication process work, then you can easily understand that. But I think that this image is very crystal clear that what I would like to say. So to protect this source and drain terminal of these two side, I need dummy in these two side, as well as I need dummy top and bottom also, to protect my this terminal also. You can understand easily, right? Okay, still if you have any confusion, you can comment in my video link. So let's go here. So you can easily understand, right, why I need this top and bottom dummy also. Now let's say how to use this. This is a very crucial question. Uh, a myriad number of students believe that we also need dummy transistor similar size as like active transistor. But if we do that, then the my entire circuit area will increase, because in analog circuitry, every machine group you should have used dummy transistor. Then in every case, if you are using the similar size transistor as like active, then definitely it will increase your area. Okay, so the research says we do not need the similar size transistor, and the industry standard is that if we use this left and right transistor, you can see I write that for the top and bottom dummy, whatever you should use W is equals to 1, whatever the active W is. If let's say the active width is 10 micro, whatever it is, but you should use the width for the top and bottom is equals to 1. And you should not change the length. If you should not change the length, okay? If the length of this active transistor, let's say 2 micro, then the length of this transistor should be 2 micro. You understand? And what about this corner, left and right corner? For left and right corner, this transistor, you also use that W equals to 1, as well as you used to use length equals to 1. In this example, as I assume that ABBA, every active transistor has L equals to 2 micro, which is greater than 1 micro, then I should use length equals to 1. But if the length of my active transistor is less than 1, then I should not change it, okay? And if you play with in Cadence software, then you can notice what happened there. So I think that this portion is also pretty clear now. Okay, so I prefer that 1 micro and 1 micro. It's not my prefer, it is the industry standard. Okay, and let's say now it is a one more crucial point, that how should connect the gate. We know a transistor has 4 terminal: gate, drain, and source, and another is back gate or bulb or body, whatever we can say. And if let's say if gate is 1 volt, drain is 1 volt, and source is also one, whatever, if this 3 terminal voltage is similar, then my this transistor is works like a dummy transistor. Okay, this transistor will not have any impact in my circuit. But never do that. I'm showing you one circuit right now. Yeah, but never do this. If I go to my whiteboard here again, and let's say new page, let's say this is transistor M1, and you would like to use this transistor as dummy. And let's say you connected the gate is node X1, and let's say if you connected these two in a similar node, let's say X2. Never do this. If you do that, basically this transistor works like a capacitor, which basically slow my circuit, which is responsible for my RC delay, and it's a lots of different things. But never do that. Okay, it will, in a real-time circuit there are lots of parasitic capacitance as well as resistance. In among these, if I also add one external capacitor in the left right corner, then it would be a problem for me. Okay, so never do this types of connection. Okay, always try to keep this all of the connection should be a similar node, one single node. Okay, this is the proper way to do this. Okay, and now if I go back to my screen, then you can see the connection of drain gate same node, and the body of the transistor may be in a similar, or sorry, maybe in a different node. For example, for NMOS, it might be in, basically depends on the designer, why, how they design it. It might be in AGND or VSS, or for PMOS, it might be in VDD node, or sometimes the designer may connected the body and the source in a same potential. It depends on the designer. For analog circuitry, it is not mandatory, or you may not expect that the body always connected to VDD or VSS, whatever we see for the digital circuitry. Okay, for the analog circuitry, if I can play with the threshold voltage. For example, if I connect the body and source in a different net, then there is this surely a voltage difference, and due to in this bulk and source, and due to this voltage difference, I can play, or the analog designer can play with the threshold voltage. And if they play the threshold voltage, they will also can play with the, there is a term VGS minus VTH, and they can modify the VTH in this way. So it's a different story, but you may not expect that the source and drain is connected together. It may be different, or might not be different. Okay, so let's say there is an example. And in this example, I am considering my active transistor is an NMOS transistor. Okay, so there might be two cases. Let's say one node is X1, another node is X2. And if it is my dummy transistor, I am talking about the left and right. Okay, the top and bottom is not a issue. We can connect this whole transistor with VDD or VSS. Mean, if drain gate body source as well as the fourth terminal of transistor is connected in the same potential, and there is an option that in simulation process or in LVS that we can pass LVS in this way, or the tools basically think that it is dummy, we can consider as dummy. Okay, it's a different issue. I will show whatever in my real life example. When I will show in Cadence, I will show this topic. But right now, let's try to understand the left and right corner transistor, how to do that. Okay, so let's say this node is X2, and if it is a dummy, this dummy transistor drain gate source also must be tied to X2 node. Okay, and let's say its body maybe not in X2 node, its body maybe, it is, I assume, NMOS, it may body maybe in VSS, right? It is possible. It is possible its body maybe in VSS, or its body maybe in X2 node. It depends on the designer actually. And the another case might be, let's say, the active one node is X1 and this node is X2. And if this node is X2, it's very fine, because in this case, I also can connect the drain body source in with VSS, as well as drain gate source with VSS, and the body we also can merge with VSS. Okay, it is also a fine connection. But however, this is the trade-off, and in this case, we also may not have any issue. Let's say channel length modulation issue, which basically is preferred for short channel MOSFET. However, because my this transistor is a dummy transistor. Okay, so I hope that you understand everything clearly, that how and why we should use dummy transistor, and how we use that, why you use that. Now let's say I wanted to show you something. However, this is a student version which I take from my university. Yeah, here. Okay, I think that you can see me. Okay, this is the thing basically I demonstrated in my first video, and it is the differential pair, and it is the matching of differential pair. Okay, you can see it is a common centroid type matching. And in my first video, I also explain why and how I do that. In this video, I will just show you that how we use dummy. Okay, nothing else. Okay, as I told you, this is my active transistor in the corner side. So here, this is my dummy, right? And my, you can see the size of my active transistor and dummy transistor is not same. Okay, it is just 1 micro as I show you in my video. And if I want to show here, I think I should select it and press Q. And then you can see if I go to parameter, the length is 1 micro and the figure width is 5 micro. Okay, and if you see my active transistor, here we can see the length and width both of it. Basically, whatever I did, I already explained in my video. Okay, so nothing to explain there anymore. And in the right corner also, you can see the dummy transistor. And this is my top layer corner dummy. This is the top layer corner dummy, and this is the bottom layer dummy. Okay, this is my dummy. And whenever I do the connection, I connected this all of this dummy with this body connection, and let's see whatever will happen there. Okay, I show also another issue there. Let's say here you can see this node is not my VSS, right? Uh, this node is not VSS. Here, I connected this body with this node, but it is possible that I also can connect this node here, not in this node. I can connect this not in source. I can connect it like as VSS, okay? If it is the case, it is VSS, okay, let's omit it. If it is the case, it is the body is VSS, then what I should do, I already explained, but I am telling you here. And this is my dummy, so its gate, drain, source should be connected with my P tail, right? This node, mean this node. This node is, you can see here, it is P tail, and the body of this transistor will go with VSS. And if it is connected like this, it entirely depends on the design. Then this everything should be in same potential, mean the body of this transistor also comes in idea for picture, but it is not the ideal case. However, I think that you can understand everything clearly. So in my next video, I definitely show you how to route this differential pair, uh, how to connect basically the VDD, VSS, or everything. And I will surely assume there is a node like VSS. I will show that how to connect that. However, I will talk on this topic in my future video, and I hope that this video is surely helpful for you. So if you enjoyed this video, please like as well as share with your friend. And I think that you surely got a real-time experience how to use dummy in circuit. And I am telling you with due responsibility, in industry, the engineers doing the same thing for top, right, left, bottom burner. They're not using the similar same dummy as like active. Okay, uh, I am ending this video here. If you have any question, please make a comment as well as subscribe my channel as well as share with your friend. Bye. Have a good day.